Me immense pleasure to welcome you to all to third day of our faculty 5 days faculty development program on recent advancement in civil engineering, organized by Department of Civil Engineering in association with the Institution of Engineers India, Bareilly Local Center, Bareilly. After a highly insightful beginning in the past 2 days, we continue this academic journey with renewed enthusiasm. Today, we are privileged to host here another distinguished expert in this field of civil engineering. We are honored to welcome Dr. Rahul Dev Garg, sir, a professor in Department of Civil Engineering at Indian Institute of Technology, Roorkee, for delivering today's expert session. Dr. Garg, sir, currently serves as a Dean of Resources and Alumni Affairs at IIT Roorkee and brings with him over 29-year experience of academic and research experience. He has leading authority in geomatics engineering with expertise in remote sensing, GIS, WebGIS, and other. He began his career as a scientist at ISRO, Indian Institute of Remote Sensing, and joined 2007 IIT Roorkee. With a PhD from IIT Roorkee, he has guided numerous MTech and PhD scholars. His scholarly contributed include 125 plus journal publication and 150 plus conference papers and several book chapters with an H index of 16. Dr. Garg sir is recipient of many prestigious honors such as National Geospatial Award in 2018, Outstanding Teacher Award, and National Geospatial Faculty Fellow Award in 2014. Doubtly, he was awarded the Netherlands Government Fellowship for Sandwich PhD in 1998 and the Excellence Award from the Institution of Engineers India. We are truly privileged to have him with us and look forward to enlightening and engaging sessions. Please welcome, sir. Please, sir.
Okay, thank you, Anikji. Thank you for inviting me, and yes, it is a pleasure to now interact with you all, your participants of the FDP. So let me share my screen. Basically, this geomatics engineering is a part of civil engineering. In different universities, you may find it that it is a part of geography, it is a part of some other engineering department. But in India specifically, this has been taken in civil engineering. So let me now share my screen. All of you are able to see the screen?
Yes, sir. Yes, sir.
Yes, sir.
Okay, good. So with this, I will just start my presentation because time allotted to me is quite less in comparison to the total content which I can share with you. So it is the recent advances in geospatial engineering. Geomatics engineering, geospatial engineering, they all are same. Like these are taken by different literature. So when we say that geospatial engineering, it is an integration of RS. RS is remote sensing. GIS is geographical information system. GPS is global positioning system and land surveying. So just combination of these all will make a geospatial engineering where you will get information about the particular land area, and then you can use it for different purposes. It is a decision-making tool. You can take decision on the basis of the data which you have collected. Market potential is huge, $2 billion per annum. So that's why so many researchers, so many students, they wish to go for this particular technique, and also it is spreading at a very high rate. India is one of the hubs. You know that India is an education hub. So that's why India has got its strong presence in the field of geomatics. and it is also a basis of the spatial information infrastructure. So in this talk, I would like to cover very less topics of geomatics engineering, although there are many more like apart from that. But okay, these are the fundamental one: geographical information system, satellite imaging, also known as remote sensing, global positioning system, and the topographic LiDAR. Topographic LiDAR is a new technique. I thought I should share it with you. First of all, we go with the GIS. How to define GIS? It is a powerful tool for solving the real world problems. You can see that we have got an area. GIS believes in splitting the information into different layers, and then the layers can be studied individually as well as in combination. So it is a method to visualize, manipulate, analyze, and display the spatial data. In fact, what you are doing, you are making the spatial data in the digital environment. So in the digital environment, you have got more capability to work on that. Then how that GIS describe a data. So you have got a small example. There is a tree. So first of all, in GIS, you want to say where it is located. So just I hope you all know about the latitude, longitudes. Suppose it is located in USA, then the latitude, longitude of the USA will be recorded. But this is not sufficient. Attribute information, the adjective information, what it is. So for the tree, the species is oak, the height is 15 meter and age is 75 meter. If you just compile all this information along with the locational identifier, it can be input to a GIS. So GIS basically requires two things: location information as well as the attribute information. So you see that we can create map for any of the area. This is an example for the Himachal Pradesh. So these are the points which are denoting a particular property. Like for example, it can be towns. There can be lines. Lines are roads, etc. So you see that roads are represented by the lines, and these are the areas, districts, etc. So you see that all the maps can be just recorded as a point, line, and area. That is the basis of our GIS. You can just include everything like that. So you all must have seen a map. So maps are available in the atlas, maps are available in the various type of records. So you see that the symbolic representation of the geographic information is shown in the map, and this map is population distribution of Andhra Pradesh. What are these different colors? These different colors are the region for the very low population to very high population. So your GIS will be able to incorporate all this information for its analysis. So we say that visualization with the information. So there can be a smart map. What is the smart map? You can have a map, but wherever you move your map, there is a separate window which will open and tell you the further information about that. Just for example, I click on Rajasthan. So regarding Rajasthan, all the information will be given over here. So it means it is a map plus database. That is the strength of GIS. So you have got a map to look at the location where it is. Like somebody want to see where is Rajasthan. It is on the western border of India. If anybody want to know what is the population, what is the number of district, how much area it has, so all this information will be available just like click. So GIS has got more than 20 million users all over the world. Around 2,000 universities run the GIS-based courses. Like you can simply search on Google, then you will find that so many universities, they run GIS-based courses, and people also register annually for that. There are this large number of users. ISRI is one company which produces the most popular GIS software. So GIS education is in postgraduate and graduate level world over, and so many countries they allow the GIS education even at school level. In India also at school level, number of schools have included GIS as a separate subject or as a part of other subject which the students read. So just for example, we take a case study from Dehradun, interactive map on the web. So wherever you click, all this information comes. You can also run a query system. So type a name of the attribute. There are two localities, Rajpur Road and the Raipur Road. So if you just place few words so that ambiguity is not there, just having RAJ, it gives you two localities, Rajpur or the Rajendra. So whatever locality you want to see, for whatever locality you want to know the information, that will be available. So now we have just GIS for the entire Uttarakhand. You know, Uttarakhand is the Dev Dham. So many these religious spots are there. So there we will be able to see all the information at a single map. Then click on the individual place, and you will get more information for that. WebGIS nowadays, everything you wish to host on the web. So you can see that WebGIS is a very simple thing. Pardon? Hello? Want to say anything? So WebGIS, you have used Google. So Google is a WebGIS because all the maps, etc., all the information is hosted on the map, is hosted on the internet, as well as it has got one more capability. You can work on specific queries. Some queries can also be run. You have a simple Google map and you want to go from one place to other place, it will show you the path. So that is the strength of WebGIS. So if you wish, you can create yourself, or if you wish, you can use any WebGIS. There is one more information, biodiversity information system. Why I have included? I just want to show you that GIS is capable of incorporating so many type of data for a particular purpose. This is the data for this groundwater. So you see that I hope you know that bore logs are there. So many tube wells or other things have been bored, and this is above ground and this is below ground. Then we have got next topic, that is satellite imaging. In satellite imaging, we work on the satellites. So you see that your satellites are taking data from the sun. So you see that this is your Earth. Earth is getting its light from the sun, and that light interacts and reflects from the ground, and that is collected by the sensor. So you can see here that from the source, and again the energy is absorbed, sometime it is scattered by the atmosphere, but the remaining amount of energy whichever reaches the sensor, that will be used for further analysis. So remote sensing is the science of acquiring information about the earth surface without being in contact. That's why we call it as remote sensing. And taking data from satellite is one of the important part of the remote sensing. You can see it again. So sun gives energy to all the ground objects. There will be different type of ground objects. The ground objects, they interact with the energy, they reflect it back to the satellite. And now there is one very important thing: the wavelength interacts in different manner with different type of objects. Otherwise, on the satellite, whatever data you receive, there will be no distinction between the data. You will not be able to identify the data. So that's why you are able to identify, and we want to use that data for our analysis. This is known as multispectral concept of remote sensing. All of you, if you want, you can note it. Multispectral concept of remote sensing. It means interaction of ground is different with different type of wavelengths, which we are using in remote sensing. So now you have got two type of satellites which are used for remote sensing. One is the sun synchronous. These are the sun synchronous which are moving from North Pole to South Pole. Others are the geosynchronous. So geosynchronous are having the equatorial orbit and they are moving at the height of 36,000 kilometers above the Earth. While the sun synchronous or the polar orbits, these are approximately 900 kilometers above the surface. So you can see here the geostationary or the geosynchronous orbits, they move at the this height of 36,000 kilometers, and it has got one specific advantage that it completes at this height. The satellite completes one full cycle in 24 hours. So what does it mean? Earth rotates in 24 hours, satellite also rotates in 24 hours. So every time satellite is in contact with the ground station. So the connectivity is established, and I hope you know that's why this geostationary satellite is used for transmission of the live event. Suppose there is a test match, some event, some sports event or anything is going on, you want to broadcast it over the entire India or maybe abroad, then the geostation satellites are very useful. They are also useful for finding out the climate effect and other one is the sun synchronous satellites. Sun synchronous satellites, they move from polar region, the North Pole to South Pole. They have got inclined orbit, and the quality of this sun synchronous orbit is wherever they move over the Earth, the local sun time is the same. Why we need a local sun time? Because if the satellite reaches a place in daytime, in local daytime, because you know that for that location, in India it is noon, but in USA it is midnight. All right. So we want the location of the satellite to be at the same local time. It means if it is at 10 o'clock morning in the place where satellite is visiting, satellite is moving and visiting other place. There also it should be the local sun time 10 a.m. in the morning. What is the advantage? This satellite, remote sensing satellite or the sun synchronous satellite is given the task of taking the pictures of the Earth. If it is able to take the picture with a similar type of illumination on the ground, you just assume it as a flash gun of the camera. So if the illumination is same, you will be able to compare the two pictures. If illumination is not same, it means one is taken in the bright sun, other image is taken in the dark time, you will not be able to compare it ever. That's why you require a specific orbit known as the sun synchronous orbit, and sun synchronous orbit gives you the remote sensing data. So you can see what specifically you have there. It is a near polar. It means it is not exactly over North Pole, South Pole. It is having an inclination with respect to the poles. So this inclination allows it to become sun synchronous. So satellite passes over all places of the Earth having the same latitude, twice in each orbit having the same local sun time. That is a characteristic of this sun synchronous one. Now, we have got one very interesting thing for you. Maybe few of you have got some idea about different type of satellites as well as different type of cameras. So we have got major three categories: frame-based sensor, a cross-track sensor, and the along-track sensor. So we will see it one by one. We will see it one by one, what individually. Let us first see frame-based camera. It is just like your normal camera. It is just like your normal camera. You see that satellite is moving in the sky. Satellite is just taking pictures to the ground, and just a format, a square or rectangular format will be captured by it. I can show you the next one again. Okay, first this one only, phased camera. Single go. So we will show you the next one, then you will be able to understand the difference. This is the across track. Satellite is moving in the sky, and it is taking the data by sweeping it left and right. It is the across track. Look, satellite is moving in the, okay, it is sweeping left and right. Designed for. Okay, USA has applied first, and this is one of the prestigious one. But this along track one is more advanced technology. This has been done by first France and then by India. You see that the satellite is moving and it is taking picture along it. So what happens now? You require a very large number of camera in the satellite which can capture the pictures simultaneously. So it is the along track. All right. I hope you have seen this, so you will be able to appreciate the thing. So now Indian Space Program, I hope you know that ISRO is doing very good work, and they have got a large spectrum of satellites nowadays in the entire space. These satellites, they have got a variety. These satellites provide you different type of information. So can you see that this is the world map and there is a red frame? What is the red frame? Red frame provides you data for that entire area. Can you see in this red frame? India and neighboring countries can be covered in a single frame. So that is given by NOVA. NOVA is an American satellite, and AVHRR is the name of sensor. So again, OCM, Ocean Color Monitor, is an Indian camera, Indian sensor. So you see that a part of about half of the North India can be taken by OCM. Another camera, WIFS, WIFS, is a wide field sensor. It can cover almost a state. The data for almost a state can be taken. Then we come for the DIS-3. DIS-3 camera is giving you more details. Can you see that from here? You are able to see one city. Again, from this place, list 3 to panchromatic, you are able to see part of the city, and afterwards, from this panchromatic to that Iconos and other type of camera, you will be able to take pictures of the roads, houses, individual. So that is the Iconos pan. Iconos is the name of satellite. PAN is a universal name for that. So Iconos data is just to show you how good you can see on the ground. Oh. Yeah. So nowadays, this spatial resolution, this details on the ground is known as spatial resolution. This resolution is going on increasing. It has become better and better. So look, we are taking a 32 by 32 kilometer area at the 64 meter resolution. Resolution means you are able to see 64-meter area as a dot. Now, you just magnify it. Now, area covered will be less, 16 by 16 kilometer, and 32-meter area will be shown as a dot. And afterwards, you go for 8-meter by 8-meter area. Here, 16-meter area is shown as a dot. You go for 4,000 meter or 4 kilometer by 4 kilometer. Here, you are able to see 8 area. We go further. Now, 1 kilometer by 1 kilometer, you are able to see 4 meter. 500 by 500 meter, you are able to see 2 kilometer. 250 by 250 meter, you are able to see 1 meter. So there are so many examples. When I go on increasing the spatial resolution, you will be able to see the details more. This is a picture of the White House, very popular structure. I hope you all must have heard the name. So this is the picture at the 1 meter spatial resolution. It means one dot is 1 meter. Here it is 1 dot is 3 meter. Here 1 dot is 10 meter. So you can see the comparison between these three. That what is the level of detail, what is the level of betterness of an image if we go for a better spatial resolution. Here, the cars are parked in a parking. So here you are able to see the car. You will be able to identify what is the front part and back part. But in other pictures, it will be difficult for you. So now ultra high resolution. So it can be 60 centimeter. It can be 15 centimeter. You see that 16 centimeter you are able to see a jet, but in 15 centimeter, even the individual rockets and other details which are attached to the sensor, they can also be seen. It is IRS panchromatic image of the Delhi area. I hope you are aware of this. This is a Kartavya Path. One side we have got our old Sansad Parliament House, and one side is India Gate. And I think somewhere here, I have not checked, somewhere here the Kartavya Bhavan has been inaugurated tomorrow. I think tomorrow or on 15th. This is having a spatial resolution of 5.8 meters. This is a IRS pan image of the Houston city, 5-meter resolution. You can just check that the clearness, the data quality of the Indian area is slightly poor in comparison to the foreign area. Satellite is Indian, everything is same. So we just attributed it to the air quality. All right. So in foreign country, the quality of air is better. That's why the radiation can penetrate the ground in a better manner. That's why you can compare these two pictures. You can see that foreign picture is in better shape. This is one more Indian satellite, TES, Technological Experimental Satellite. It can give you 1 meter resolution image of the Barcelona. So you can see that all these planes and other areas which are parked over here, they have been seen very clearly. This is again for the hangar, airport hangar. So TES 1 meter image. So perspective view can also be seen. Perspective means those buildings which are quite high. So look at the view. You will be able to see it just like a satellite image. So whatever you are looking, so this satellite image will just show that you are flying over that area. So this is a Coliseum in Rome. So it is the Iconos satellite 1 meter spatial resolution image. So I hope you all have heard the name of Coliseum. It is a part of 7 wonders. You see that all those areas can be viewed very clearly. This is a list 4 image. So list 4 means so far we have seen the panchromatic image. That's why they are black and white. List 4 is a camera which can give you multispectral image. Then using the multispectral image, we can produce the colors. The colors can be produced falsely. Falsely means you don't follow the nature's law. That's why we call it as false color. If you follow the nature's law, then you call it as natural color composite. But please see that the interpretation of the natural color composite is little inferior in comparison to the false color. So we can say sometimes false is also good, because just having artificial colors to different ground area, you will be able to extract the information. So information will be available in a better. Now satellites have got so many capabilities. So satellites are viewing just in the vertical side. We call it as a nadir viewing, NADIR. We call it as a nadir viewing. But with the technological advancements, now the camera can be tilted, camera can be turned. So ideally, the camera is looking in the vertical direction, but the camera can be tilted and the camera can look in the direction which is away from its path. Can you see here? The camera should look below, it should look this point. This camera should look below and looks this point. But what has happened? The camera has been tilted and it is viewing this area. So what is that? It means that if there is an important phenomenon, if there is a phenomenon like cyclone, flood, or any other, which you want to record, which you want to study, it is possible by the single satellite on the multiple days. So you will be able to capture the data in multiple manner. So I have told you about monitoring hurricanes or cyclones, etc. So can you see that movement of cloud and how the hurricane has been formed? That has been shown very clearly over here. Now, this is a very interesting image. I hope all of you can identify the structure. This is Eiffel Tower in Paris. So you all can see it is a satellite image of the Eiffel Tower in Paris. So I have just included it to show you one special thing. This is satellite image from the height of 900 kilometer. This is aerial image from the height of 2 kilometers. All right, for the Paris city, Eiffel Tower has been captured, and you see that in the previous image, the angle of viewing is not very important. So you can see it with the same angle of viewing, so that you have got a similar type of view. But you can just compare the details which have been recorded by the satellite. So that is very important. That is very important. And you can see on this side, this is a world view data. And it is 0.5 meter spatial resolution. So this is the capability of your satellite system. I hope most of you will identify. This is Lotus Temple, New Delhi, again captured by the satellite. This is one very famous. Can you see the roads and how they are moving, etc.? It is the Judge Harry Ferguson interchange in Los Angeles. What is the specialty? This has been used for number of Hollywood movies to picturize the stunt scene and the car racing, etc. This is again very interesting thing. You find a number of circles. People may worry why these circles are formed in India. These are natural. These are not these are not painted in color like this. So these are the agriculture fields with the sprinkler irrigation. I hope you know, in the sprinkler irrigation, it sprinkles it in the circular manner. So you sow the crops only in this region, only in this region. So this picture is from Israel. Israel has got much area as desert, but they have just changed their desert into very good agricultural land. This is again one interesting picture. These are the just vineyards. so which are having stepped cultivation. So stepped vineyards in Germany. You see that how good they appear. This is again, this is also a stepped cultivation, but this is for rice and other things. These are the rice fields. Again, dots, these dots are the cattle farm. So you see that how good we are able to see from the satellite. Okay, this is an urban planning city has been planned in this manner. This is in New York City, a specific type of planning. This is in Iceland, Reykjavik. This is the barefoot bay development in the Florida. You see that the pattern is just like a pentagon. So they have taken the pentagon pattern in order to do this. Now, I will just show you one very interesting thing. So you see that this is a picture where you can see the mountains, you can see a river, you can see some agricultural land. Oh, picture is moving. How the picture moves? The picture moves because we have created a system where the data has got multiple levels and it is just like virtually flying. So it is a digital elevation model which is derived from the satellite data. So this is known as virtual fly-through. So this is Goa region and this is the Mandovi River and some mountains on the nearby. So now we will go for the next part, that is GPS, Global Positioning System. So global positioning system is again a very interesting topic. Uh, Although we all know that GPS is available in our mobile phones. Nowadays, almost everybody is using GPS, but in this discussion, we will like to see the basics of GPS, the fundamentals of GPS. So GPS is a satellite navigation system. It navigates using the satellites. So it provides us the instantaneous position, velocity, and time information almost anywhere on the globe at any time and in any weather. So it means that if you want to go on expedition, if you want to go for any army mission, then you will be able to use GPS in order to know where you are. So it has been developed by US Department of Defense. There are 24 satellites in 6 orbits. So satellites are moving at an altitude of 20,200 kilometer. Satellite life is about 7.5 years. So it is a one-way communication. It means that the GPS satellite can only receive the signal. They cannot give the signal, or you see that it is having that 12 hours period and orbit precisely predictable. This is started for the civilian use from 1995. You see that earlier it was used by the military only, and that too US military only, but slowly in 1995 they have allowed the civilians also to use this. Okay, so it is your definition. So that we have seen already. So it is the GPS system. Like every country have got its GPS system. So we have got Navistar by USA, GLONASS by Russia, Galileo by European Consortium. So many countries they have joined hands. BDS is Green is Navik. I hope you might have heard any one of the name, IR or Navik. So this is basically used for positioning resource, and GPS can provide you too many type of accuracies. So it can be 100 meter, it can be 5 to 10 meter, 1 to 2 meter, but you should know what is the logic, what is the technique behind it. If you are using the navigational or the handheld GPS receiver, then maximum accuracy you will achieve is 1 meter. All right, because handheld GPS receivers are cheaper in cost, and you will be able to take data very fast. But if you want centimeter level accuracy or you want millimeter level accuracy, you have to go for long time observation. You have to change the equipment. It is a geodetic GPS receiver. It means that if you change your GPS receiver to geodetic, you will expect better. And obviously, the higher accuracy involve a greater infrastructure and thus the greater cost. So it depends on your purpose, that what level of accuracy you want to achieve. So GPS has got three segments: space segment, control segment, and user segment. You see that in the space segment, your satellites are located. So this picture is for the Navistar by US. There are total 24 satellites in 6 orbital planes. They are moving at the height of 20,200 kilometer. 55-degree inclination is there. And the purpose of these type of orbit is like that at any moment, minimum 4 satellites should be available to a user, because we require 4 satellites in order to compute our location. That we will see, that fundamental we will see. Next is the control segment. In control segment, we have got 5 control segments with 5 control centers, which are just situated along the equator. These are for monitoring the orbits, that if any satellite is deviating from the orbit, as well as these can just send the command to the satellites. And Colorado Springs is the master control. Next, user segment. We all are situated in the user segment. So in user segment, if a person is having a GPS receiver in hand, the person can communicate. Look, yellow line is for one-way communication. The user can communicate with the satellites, and it can capture the data. And you see that control segment means there is a two-way communication possible, and control segment can control. It can give commands to the satellite for various purposes. Different type of GPS receivers you can see here. And here we have got the geodetic GPS receiver. You will find that GPS can be used in the air, GPS can be used on the ground, GPS can be used on the sea. So just note that GPS can't be used in caves or below the surface of Earth. It can't be used underground. GPS can't be used below the surface of water. Why? Because GPS signals are weak. GPS are not able to penetrate walls, penetrate water, etc. But this is a very good representation that GPS can be used in the air, on the ground, and on the sea, or means on the water. So this is one of the very fundamental slide which you will wish to know. What happens? Suppose there are 4 satellites in the sky. I told you that minimum of 4 satellites are required to calculate the 3D position X, Y, and Z. X, Y, Z is the 3D position where suppose one user is standing which wants to know the coordinates of its location. So we have got 4 satellites in the sky. The orbit of those satellites have got the coordinates. We will know those coordinates because orbit is known. So it is x1, y1, z1, x2, y2, z2, x3, z3, x4, y4, z4. And individual satellite is at a distance of r1, r2, r3, r4. All right. So this is the setup. Now, what you should do, you have to find out the small x, y, z. And for that, you prepare the equations. These are the simultaneous equations. Simultaneous equation are also used in your coordinate geometry. R1 is equal to square root of x1 minus x whole square plus y1 minus y whole square plus z minus z whole square. That is a formula for one range. Can you see? This is a formula for one range. Then first range, second range, R2 is equal to the same formula, R3 is equal to the same formula. All right. So we have got three unknowns, small x, y, and z. We have got three equations. We will be able to solve the three equations for finding the value small x, y, z. But here we are writing that minimum of 4 satellites are required. So why 4? Please note that the fourth satellite is required for the correction. So without correction, whatever coordinates we compute, they will be waste, because without checking, without applying any correction, we are not able to get the correct values. That's why we say that minimum 4 satellites, because 3 satellites for computation, 4 satellites is for the cross check. One more type of GPS setting you can see. So here we take a pair of the satellites. We take the pair of the GPS receiver. This is roving, that's why it has been shown as a moving band. This is fixed, that's why it has been shown on the top of a tower. So basically what we do, if we take the data from the 4 satellites by the same location, this location as well as this location, if you compare the two, you will be able to get the error. And that difference in error, if it is applied to the signal, you will be able to increase the accuracy. So it is a tested approach. This is a tested approach, and applying the real-time differential GPS positioning or the relative point positioning, you will be able to get more accuracy from the GPS. So some GPS applications like mobile mapping, location-based services, emergency services, tracking. You people nowadays must be having GPS as well as GIS in your cars. So navigating the given location, the same thing as we do on the Google. So many applications are there for the GPS, recreation, road transport, aviation, public services, etc. Now, we go for the last part of this discussion, that is LiDAR. LiDAR stands for Light Identification and Ranging. LiDAR, Light Identification and Ranging. This uses the laser light. Okay, the equipment uses the laser light. These are the wavelength range, which is usual, ultraviolet, violet, and infrared region. So laser, I hope everybody knows, light amplification by the stimulated emission of the radiation. All right. So many wavelengths can be used, and basically what we do, we just mount the laser-based camera in the equipment, and equipment takes the data for the ground. Just look, equipment is taking data for the ground using the light detection and ranging equipment, LiDAR equipment. So it is first developed in 1960 by the Hughes. Modern computers and DGPS make it practical. So basically, the LiDAR has got the advantage that it is able to capture data on the ground with very high accuracy. Because you all know, laser can be directed very accurately to the point. So when it is a laser beam, you will be able to record the XYZ position with very high accuracy. That's why this LiDAR sensing is popular. So this is the airborne LiDAR camera ALS50 and the digital camera over here. So you see that the flight moves and the flight takes the data. This we will see it again. You look, it is coming. So the first return is there, second return and the third return. So basically all these data, one advantage for the LiDAR beam is having good energy. So that's why you see that even if it has encountered a collision at the top of the tree, but the remaining amount of the radiation will continue to the downside, and you will get first return, second return, and the third return. So this is a picture. When you see that a bridge, the points on the bridge can be easily taken over there, just like your person is viewing when it is flying. The one advantage for laser data, for the LiDAR data, is that it captures each and every position very accurately, so the coordinates can be measured very accurately. If you take a normal picture, if you take a normal camera picture, you may see the same type of view, but you will not be able to measure it. Okay, so if using the LiDAR data, you are able to measure, then it means that you can do any structural design on that. So again, discrete return LiDAR. So it is taking you the data for the ground area of 1 kilometer by 0.75 miles. So here you can see various advantages are accuracy, time of data acquisition is in your hand. You need not wait for sunrise, you need not wait for sunset. Minimum user interference is there, weather independence, additional data, canopy penetration, ground control points, dependence, and the digital compatibility. So all these are advantages. So you see that LiDAR captures the 3D information. So suppose there are scrubs, etc. It will capture. It will capture. If you are not interested in these scrubs, so what it can do, it can remove them also by 3D processing. See that all these vegetation have been marked over here. We apply a filter and all these will vanish. So Delhi area ALTM, it is an airborne area. So the laser image ALTM. So from the previous image, it has been processed. So buildings can be extracted and you can prepare a good 3D model. So LiDAR means you are able to capture things at good accuracy. That's why everybody knows that if it is LiDAR prepared, so people give it more importance. So again, it is LiDAR in the larger topographic surveys. You can see the entire waterfront. Entire waterfront has been marked. So I hope you all know this figure. It is India Gate and capture of India Gate features using the 3D terrestrial laser scanner. So again, if you want to restore it, if you want to do some analysis, you will be able to do it very. This is Humayun Tomb. So we have done a work for the Humayun Tomb for a part of the Humayun Tomb in New Delhi has been damaged. That's why they tried to fix that problem. This is the closer view of the Humayun Tomb. If we see more closer view, you can appreciate the level of details which are captured. This is again very important building. It just looks like the Taj Mahal, but it is Bibi ka Maqbara at Aurangabad. Scanned using the laser data. So what is the advantage? You will be able to measure these distances. Okay. So like for the observatory, be very, very accurate. So with this, we can finish. We can give 5 minutes answer. If anyone of then he or she. Yeah. Any questions from the audience?
Have any query, please ask them to know, either directly or in the chat box. Please. I think,
Hello.
yes, sir, yes, sir. I think no, sir.
No questions? All right. Okay, then
Yes,
I
sir.
think you have got another session at 4. Hello.
Yes, sir, yes, sir.
I think you have. I think you have another session at 4.
No, actually today
At
is
4
no.
o'clock you
No, 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 today, sir. Today
have.
no,
Okay.
sir.
Today no session. Okay, but I have got a meeting,
Okay, okay.
so I have shifted it to 4:15. So if there are some questions, I will be able to answer here. If there are no questions, then
Yes.
thank you all.
Thank,
Thank you
thank,
for your patient hearing.
thank you very much, sir.
All right.
The
It's a
Dr.
pleasure.
Rahul Garg, sir,
Okay.
for your deeply insightful and technically rich session. Your presentation on visualization with the geospatial information, smart maps, and the current global status of GIS has greatly broadened our understanding of geoinformatics and its practical application. Your application of web GIS, biodiversity information system, and remote sensing technologies, including the multi-spatial spectrum, geostationary and sun-synchronized satellites, and frame-based imagery techniques, was highly enlightening. The comparison between a cross-track on along track sensors added deep depth of our understanding of satellite data acquisition. We are particularly interested in your session on IRS plant imaginary, its role in monitoring agricultural land and cattle farm, as well as the generation of digital uh, elevation model derived from the satellite data set. This session on LiDAR technologies, highlighting its precision, data density, and the role in 3D terrain modeling, was especially valuable, sir. Additionally, your insights into GPS, including control segments and 3D positioning principles, were highly informative, sir. Once again, thank you, sir, for valuable time and contribution, sir. Thank you, sir.
All right. Thank you. Bye bye. Thank you. I am signing off.
Uh, Now, I will sharing the midterm exam come feedback form link. Kindly ensure that your submission your response on time. Time for feedback link time for 30 minutes. I will share you. Second, please. Please access the link. I think link is working.